Hello, good morning. Good morning. Hello, let's start. So I'm going to ask you to sit down, please. Thank you all for joining one more WavEC seminar. This time we are gathering with the Embassy of Norway, Innovation Norway, and the Norwegian Offshore Wind Cluster. You are very welcome to this event. Before I give the word to our CEO, Alves, we want to present a very short video about WavEC, and then I'm going to ask Mark to come on stage and open the session. So thank you very much.
WavEC combines research and development with specialized consulting. To address today's energy challenges, we go beyond the state-of-the-art, developing cutting-edge solutions in marine renewable energy, shaping the future of an emerging industry. We bring a proven track record, R&D powered and market-focused, with flexibility to meet each client's unique needs. With a highly skilled, multidisciplinary team, we are a globally recognized reference, taking a holistic approach to solve complex problems, supporting the development of a strong supply chain, while respecting and integrating the marine ecosystem. Discover WavEC. Join us, powering the future with sustainable offshore renewables.
So Marco, can you please come on stage?
Your Excellency, Ambassador Hanne Brusletto, Secretary of State for Maritime Affairs, Lidia, Bulcão, dear guests, good morning and welcome to WavEC seminar, this year organized in partnership with the Embassy of Norway to Portugal, to whom I extend my heartfelt thanks for the support, for the engagement, as well as to all our sponsors. It is both a privilege and a deep honor to welcome you all to discuss a subject of profound relevance to our shared future, offshore wind energy. Offshore wind stands at the intersection of three critical priorities for Europe, and not only Europe. The first is decarbonizing our economies. The second is ensuring energy independence, or at least mitigate energy dependence. And the third is strengthening energy security. These are not just policy ambitions, but imperatives in an era marked by urgent need for sustainability and growing geopolitical challenges. Recognizing this potential, the European Union has positioned offshore wind as a cornerstone of its energy transition strategy. Initiatives such as the European Green Deal or the Offshore Renewable Energy Strategy, or funding programs like Horizon Europe have been crucial in fostering innovation, fostering research and infrastructure development. These actions highlight the EU firm commitment to reshape our landscape, our energy landscape, and achieving a sustainable future. Although, as promising as this vision is, it presents significant challenges. Aligned with EU directives, the simultaneous widespread push for offshore wind across many countries in Europe creates a huge pressure on the supply chain that is still, as we all know, in its infancy. While many nations in Europe are taking the first steps to comply with EU directives, countries worldwide, other countries, are also rolling out offshore wind initiatives, further straining global resource and infrastructures. This supply chain pressure is at the heart of our discussion today. This is not merely a logistical issue, it's much more than that. It is a strategic one that calls for collaboration, calls for cooperation, innovative thinking, and long-term foresight. The aim of this seminar is to explore how cooperation between Portugal and Norway, in which WavEC aims to be actively involved, of course, can help address these challenges. Both countries share a deep commitment to offshore wind and hold complementary strengths, alongside, as we all know, a rich maritime heritage and a profound connection to the sea. By working together, Portugal and Norway have a unique opportunity to build a robust, efficient, and sustainable supply chain that not only support the individual goals, but also contribute meaningfully to Europe's broader energy transition. Through cooperation, shared expertise, and innovative strategies, I'm deeply confident that we can overcome the challenges ahead of us. More importantly, we can establish a model for international cooperation in offshore wind development, one model that combines ambition with mutual benefit. Thank you all for being here. Thank you all for your dedication to this crucial field and for your contributions to the important discussions ahead. Let us work together to pave the way for a future powered by clean, powered by sustainable, and powered by secure energy. Thank you very much, and welcome.
Now we are going to see a video from the embassy. So now I'm going to ask the ambassador of Norway in Portugal, Hanne Brusletto, to come on stage, please.
Good morning, everyone. Your Excellency, Secretary of State, Mrs. Lidia Bulcão, dear Mr. Marco Alves, dear representatives from the Norwegian offshore wind cluster from Innovation Norway and all the Norwegian companies present here today. Dear friends, this is a very exciting day. I am thrilled to welcome you to the WavEC annual seminar with a focus on fostering the development of the offshore wind supply chain in Norway and Portugal. Let me start by thanking WavEC, the Norwegian Offshore Wind Cluster, and Innovation Norway for all your collaboration in the preparation for this seminar. Allow me also to give a special compliment to the Portuguese government representatives present here today. The Secretary of State for Maritime Affairs, Lidia, Bulcão, and in the closing session, the Secretary of State for Energy, Maria João Pereira. Your participation here today clearly demonstrates your government's enduring commitment with Portugal's ambitious climate policy targets and the development of the offshore wind sector. Like Portugal, Norway is a pioneering nation in floating offshore wind, and we see it as a unique opportunity to develop a strong and world-leading industry. For decades, Norway has successfully developed innovative offshore solutions in some of the most demanding conditions in the world. In the transition to renewables, Norway is playing a leading role in the burgeoning offshore wind industry, especially in floating wind. Norway has a competitive edge from over 50 years in designing, installing, and operating offshore facilities in extremely rough conditions in the Atlantic Ocean. And currently, as you will learn more about today, we have strong positions across key stages of the offshore wind value chain, offering a wide range of services, equipment, and solutions for offshore wind farms. The Norwegian government is also making significant progress in following up on its ambitious plan to allocate project areas for 30 gigawatt offshore wind by 2040. The next project areas for development of offshore wind on the Norwegian continental shelf will be announced in 2025. Our government is also proposing a 35 billion Norwegian kroner support scheme dedicated towards the first floating offshore wind tender that is intended to accelerate the development. The government aims to conduct the next tendering round for offshore wind in 2025, and thereafter, it intends to hold regularly scheduled tendering rounds and state aid competitions leading up to 2040. Dear friends, we see 2025 as a pivotal year in both the Portuguese and Norwegian markets. With the update of the ambitious Portuguese decarbonization targets and plans for the development of this sector, we have seen a strong interest from Norwegian companies to do business here in Portugal. In the past couple of years, our embassy welcomed several Norwegian business delegation visits to Portugal focused on this sector. And we have established strong partnerships with Portuguese key stakeholders like WavEC. We also had the opportunity to take the Portuguese stakeholders to Norway this summer and share with them our experience firsthand. In our interactions with the industry stakeholders, we learned that Norwegian clusters and businesses assess Portugal as an important offshore wind market, and that there are great potential synergies between the Norwegian and the Portuguese supply chains. These potential partnerships cover research, innovation, and commercial opportunities, and can go multiple ways, enabling opportunities in the Norwegian market, in the Portuguese market, and also towards the broader European market. And these partnerships are already underway, as for instance through the cooperation agreement signed last year between the Norwegian Offshore Wind Cluster and WavEC, as well as with other important Portuguese stakeholders. I can also mention the hypothesis partnership between the 5 test sites in Europe on floating offshore wind, where Companhia da Energia Oceânica from Portugal and Met Center from Norway are partners. The expertise developed in both countries is a real value for the delivery of innovative and competitive technologies, solutions, and services for the upcoming offshore wind projects in Portugal and Europe. To conclude, I want to wish you all an inspiring seminar today, as well as fruitful B2B meetings tomorrow. And once again, thank our co-sponsors for this organization. In their own way, both Norway and Portugal have been pioneer nations and are global references in the floating offshore wind industry. Let's take this opportunity together. Muito obrigada.
So now I would like to ask Lidia Bulcão, Secretary of State of Maritime Affairs, to come on stage, please.
Good morning, ladies and gentlemen, Honorable Ambassador of Norway to Portugal, dear CEO of the WavEC Offshore Renewables, distinguished guests, welcome to Lisbon and to the beautiful Fundação Oriente, an exceptional venue that reflects both Portugal heritage and its deep connection to the sea. Today, we gather in this iconic setting to discuss a vital and timely topic under the WavEC annual seminar organization, to whom I thank the opportunity to address the need to foster offshore wind supply chain development with a special focus on the collaboration between two proud maritime nations. Portugal and Norway share a profound bond through our history, geography and economies which are deeply linked to the ocean. Both nations have long embraced the sea, not only as a source of identity, but also as a foundation of innovation and growth. In this era of climate urgency, our shared maritime heritage positions us uniquely to lead in developing sustainable ocean-based solutions, particularly in offshore renewable energy. Portugal is committed to this vision, and we are already taking decisive steps to turn ambition into action. An essential instrument in this process is maritime special planning, in which Portugal was pioneer. With the recent approval of the Maritime Special Planning Plan for the Azores subdivision, Portugal has now a complete and updated planning instrument that covers its entire maritime domain. Next step will be the approval of the Offshore Renewable Energies Allocation Plan, known as PAER, already in legislative state. Once approved, PAER will serve as a solid basis for the development of the offshore renewable energy sector, responding to the great expectations of the industry and of the market. In addition, the rules of procedure for the technological free zone for renewable energies of ocean origin, located off the coast of Viana do Castelo, are set to be signed today. This technological free zone will enable the testing of innovative solutions and the generation of knowledge critical for future commercial applications. All these regulatory instruments, prioritized from the outset of our mandate, will ensure that marine resource exploitation is both balanced and sustainable, while creating new opportunities for economic growth and technological innovation. Looking ahead, floating wind platforms are a key pillar of this strategy, unlocking access to consistent and powerful wind resources further offshore. These technologies align with our climate goals under the Paris Agreement and the UN Sustainable Development Goals, particularly SDG 13 on climate action and SDG 14 on conserving marine life. To achieve this, our government is investing notably under the Portuguese Recovery and Resilience Plan. This includes a €42 million investment through the Repower initiative, which supports extensive geophysical, geotechnical, wind, wave, and ocean current studies across at least 2,000 square kilometers of the Atlantic. Last September, under this initiative, took place the largest oceanographic campaign ever carried out on the Mário Ruivo research vessel by IPMA. This campaign marks a critical milestone in assessing the geological and geophysical potential of Portugal's maritime areas for offshore wind energy. This data-driven approach ensures that our expansion of renewable energy is both efficient and environmentally responsible. Another important investment under the Portuguese Recovery and Resilience Plan is the Abazul Portugal. This is a 90.3 million euro initiative aimed at creating a network of infrastructures near the ports, focused on boosting the blue tech and emerging areas of the sustainable maritime economy, namely the offshore renewable energy. By boosting research and the development of new technologies, the Abazul Portugal will be a meeting point for scientists, companies, and entrepreneurs, promoting the creation of synergies that will put Portugal at the forefront of blue innovation. This network of infrastructures will not only provide the necessary conditions for the development of new ideas and technologies, but will also create a vibrant innovation ecosystem where companies can test and scale up their solutions with the technical and scientific support of national and international experts. Portuguese ports will also play a pivotal role in supporting the development of offshore wind and marine renewable energy supply chains. They are well positioned to serve as strategic hubs for the production, maintenance, and operation of offshore wind farms, as well as key points for the export and distribution of renewable energy equipment to international markets. Ports should act as catalysts for collaboration among public institutions, private industries, and academia, driving technological advancement, sustainability, and workforce development. These synergies will strengthen economic growth and ensure resilient, future-ready supply chains. Portugal's commitment to the offshore renewable energy sector extends beyond infrastructure. We are facilitating access to funding and promoting research and development of new technologies. Our efforts also focus on helping blue business scale their operations internationally, ensuring that Portugal's innovative solutions find global markets. These initiatives are part of the broader Accelerate the Economy program of the Ministry of Economy, which emphasize growth, competitiveness, internationalization, and innovation. This comprehensive approach is crucial for a sustainable blue economy, one that balances economic development with the preservation of our marine ecosystems. Offshore wind, wave, and tidal energy projects are advancing rapidly worldwide, and Portugal is proud to be at the forefront of these developments. In particular, floating offshore wind stands as one of the most promising avenues for renewable energy expansion. Our strategic investments, coupled with strong international partnerships, position us as leaders in this field. Norway, with its expertise in maritime technology and offshore engineering, is of course a natural partner in this endeavor. By combining Portugal's vast maritime space and scientific innovation with Norway's experience and offshore technological expertise, we can build a robust offshore wind energy value chain that creates high-quality jobs, attracts investment, and reinforces energy independence in Europe. Let us seize this opportunity to strengthen our partnership and make meaningful progress toward a decarbonized future. The insights and ideas shared here today will serve as a blueprint for the next steps in realizing the full potential of offshore wind energy. As we embark on this journey, we must remain committed to fostering international collaboration. Open debate and dialogue represent an opportunity to exchange knowledge, align strategies, and develop the supply chains needed to scale offshore wind energy while ensuring sustainability and inclusivity. Ladies and gentlemen, the ocean is not just a source of challenges, it is also a wellspring of solutions. By harnessing its energy responsibly, we can contribute to a decarbonized future while protecting the ecosystems that sustain us. Let us seize this moment to build a cleaner, more resilient and prosperous blue economy together. Thank you for your attention. I look forward to the insightful discussions and innovative ideas that will emerge from this seminar.
So now we are going over to the first session. I'm going to ask the moderator of this session and the speakers to come on stage. So Nuno Antunes from Miranda law firm, his partner and co-head of energy and natural resources practices. Please, Paulo Partidário, DG EG, you can also come on stage. Daniela Ribeiro, DNV, Source Galileo, Gunnar Birkham Land, Inigo Vianney, Quer, and Ricardo Rocha Paiva. So,
thank you, Jeanette.
Thank you. I'm going to pass the word to you.
Good morning, everybody. I was already introduced by Jeanette. I'm a lawyer, but I'm a strange kind of lawyer because I spent 25 years of my life in the Portuguese Navy. So from crash tests of petroleum tankers to bathymetric surveys, I've done a bit of everything. So I'm that kind of lawyer. I'm very happy to have this panel, very knowledgeable people. I'll try to make it interesting for all of you. A point of note, the panel will have two parts in principle, in addition to Q&A. We will have two short keynotes, one by Paulo Partidário, who I introduce in a minute, and Daniela Ribeiro will also introduce after Paulo. And then we'll have a discussion with the three remaining members of the panel, who I will introduce in a minute. Paulo Partidário is going to be our first speaker. He is with the Portuguese regulator. He is the head of research and innovation unit, renewables unit at the GEG, the Portuguese regulator, and he chairs the scientific committee at the GEG. He has a PhD in strategic planning, innovation, and sustainability by Delft, and is a very knowledgeable person about anything that has to do with renewable energy, integration, co-location, services. He knows all about it, and he's going to have the tough job of a balancing act between what he can say and what he knows, because he can't say everything. That's what happens with public officials. Paulo, the floor is yours. Thank you.
Thank you, Nuno. Do we have a beamer? I would start by... Behind me? Okay. Okay, yeah, thank you. Thank you very much for having me here. I'm sorry, I'm just disclosing too soon. Yeah, well, it's it. Thank you very much. Bye-bye. So, thank you very much for this invitation. So, I'd like to thank WavEC in particular, but also to all of you to be here, because for us it is vibrating what is happening in Portugal. In my particular case, I would say that this is a quite young experience for DGEG to have a group dedicated to research and innovation from the point of view of the policies, and also to integrate that with the different scenarios where technology can develop and also be adopted. And so all this makes a lot of sense. I would say that my main field of work is hydrogen, from the point of view of not just producing the molecule, but transforming it as a PTX approach, within the different strategies it has related to it. But all that said, I will try also to make a short note on the hydrogen in between, but that will be for later. So as Nuno said, thank you for helping me to solve this equation about what I know, what I cannot say. I would say that, so this is a brief note. I will take advantage of this 10 minutes the best I can. So this is just an idea to give you an idea. So Nuno challenged me to say from A to Z what we can do. This is a sample. Within DGG, we could, in the policy support, we could include as well the interministerial group for the auction. But I would just mention in particular the technology-related issues, because as you understand, there are issues that are still running from the point of view of the auction, so I'll try to disclose what is possible. And I checked that. There was a cross-checking last night with my Secretary of State, so it's what we can say now. From the point of view from the policy till the cooperation, we have projects that are co-funded by the European Commission. We have collaboration in not just in the projects, but in working groups in Europe. Basically, mainly it's about Europe we're talking about, but still we have also some learning and sharing within ARENA and also IEA. And in particular, in the case of IEA, there'll be a particular TCP where I could say something more later on. Just to mention some issues that are drivers for our approaches, where we try to help our bosses, our directions, and our Secretary of State in order to make proposals that can be useful for the policy design and implementation. But all that, and I cannot go too much, it's just highlights of what we can do and what we know how to do. It's very much about the integration of the offshore renewables. Today we are focusing more on wind, but we know that the wind will profit if we can think about how to integrate that from an hybridization point of view. That's what we are doing with hydrogen, and sorry, and also with co-location, because we have also from the published results we get from different groups, we know that co-location also can bring benefits and cost reductions. So we can, in fact, have multiple effects when we have a systemic and integrated point of approach. So all that said, that icon that I just dropped there in the top top right is our symbol for the hydrogen offshore hydrogen production inside IEA, where we have already some countries all together, and we are having a vibrating group that also includes DNV, APREN, so we can also have some stimuli to translate that into our own national framework. All that said, so we have an ambition also, because from the hydrogen lessons, we took also these key issues about the value chains. So it's not just about the supply chain, but about also the value chain from the economical point of view, but also from the point of view of the stakeholders and how we can address the different challenges, in this case about the innovation within the wind sector. And learning also from the experiences abroad, in particular from Europe. We can say, in fact, that it is very important to take advantage not just of the technical issues, but also about the non-technical issues. They are quite important, and it's the whole world of challenges around. I would say, before we start, it's like a kind of equation system with different passes where we have to take advantage of different parameters and know exactly where to go based on the conditions we have on the current situation, and trying to design and foresight what can be useful for the next stages. So all that we try as well, we are not addressed that today, but what we can say, not specifically from the point of view of the wind technology, I would say from our point of view, national point of view, we are also being prepared to make energy analysis from a systemic point of view to the national economy. It's not there, but what we are doing today, we had already the experience that when we put some technologies in our radar, our behavior in terms of the decarbonization process by 2050 will be profiting from all this, from hydrogen integrated as well in the system, and other renewable energies. So that's it. So we are following all that. We have specific people allocated to this area. We are following the academia. We are following the different groups, and we try to take this on board so that our equations take advantage of the sensibilities and specificities of each case. I have not too much time. I would. It's blocked. Yeah. Okay. So just going to the auction, it's a common diagram that you have seen around. We are still in that left part that we dashed square. But what we have, the two phases, it is still like that. That was the result of a survey that was done to promoters. And so we adopted this two stages process. And yeah, so the diagram is just indicative. This is not yet approved by the government, but still it's the common issue around the two stages, access to the 2PEM, and then getting ready to the next stage with the first auction to accede to the TRC. What I would like to say about this, besides not having the approval yet, I would most likely take advantage of this last slide that is very much about the auction itself. So it's the common goals about scaling the energy capacity. We are having physical limits on shore, so it's really a new paradigm that is opening now. And it's very interesting for different points of view. This is also a chance to explore the Net Zero Industry Act, where we have, in fact, chances to identify, we are doing that already, identifying parts of the value chain where we can contribute to. And this will help us also to promote interaction with the stakeholders, and so that we can help our Secretary of State on that. About the specificities, we were told that they are not yet defined, so we just have today, currently, the issue is about having an application on the SEF energy area, so we can be prepared. We are preparing that application so that it will be useful for the infrastructure approach. And also there's an approval process at DGRM that is addressing the allocation plan for the offshore renewables. So this is running already. Finally, what we can say about the prospects for the offshore renewables industry, we are very much in line what Net Zero Industry Act can offer. We are working on that, and we are also sensitive to the experiences about what the lessons we can take from the offshore wind energy that decade that brought us a lot of experience, and we can in fact think and how to equate an industrialization process based on the conditions that we have. Thank you very much.
Thank you, Paulo. Amazing job. You kept to your 10 minutes. Daniela, next is you. Daniela is the market segment manager for Portugal at DNV. Of course, she doesn't know only Portugal. She knows Portugal and a number of other countries surrounding these offshore wind technology. She's been focusing on pre- and post-construction analysis, inspection, and verification of power systems. And she's going to give us an overview of what we can find in floating offshore wind these days. Thank you, Daniela.
Thank you, Nuno, and thank you, WavEC and Norwegian Embassy of Norway for inviting DNV to present here today. As Nuno was saying, DNV is actually a Norwegian company which is established in Portugal since the 60s. We provide energy systems and maritime advisory services, and for offshore wind, we have been providing consultancy and certification services for most of the wind farms that are operating nowadays. Moving forward, so where are we today in offshore winds? We have seen in the past years very significant short-term challenges. The cost inflation and supply chain disruptions have led to an increase of costs. We have seen the levelized cost of energy for bottom fixed wind increasing 30%, and we have seen a number of projects being cancelled or delayed. In particular, we can mention the US, where 9 projects have been cancelled or had to renegotiate their offtake agreements. In parallel, we are hearing from manufacturers that they are decreasing their profits and margins and they are having concerns. We know, for example, that GE stopped receiving new offshore wind orders, also considering the backlog that they have at the moment, but also the economical situation. Other than that, there are other points that I wanted to touch briefly. The fact that renewable capacity is growing faster than the grid development, the fact that cost learning effects are still very suppressed because technology advancements are still going quite fast, and local content requirements are great in a way because they help to develop the local supply chain, but they come at a cost and potential delays to the project development. Other than this, well, worth to say, always policy uncertainties. In the US in particularly, they are facing a lot of uncertainty now with the latest election results. These short-term challenges are not showstoppers for wind, though. We expect that the situation will change as the interest rates start to fall and also the government start to improve their incentives. We have the examples, very positive from this year in the UK, where the strike prices were increased and the results of round 6 were much better. Also, it's worth to say that this year we have seen the first commercial-scale floating projects being awarded, which is very positive. Looking at the long term, we expect offshore wind to significantly grow. In DNV, every year we issue a report called Energy Transition Outlook, and we estimate that by 2050, there will be 1 terawatt of bottom fixed offshore and 200 gigawatts of floating offshore. We also expect the cost to decrease quite significantly, bringing offshore wind to be much more competitive with other technologies. So bottom fixed should see a LCOE going down to $67 per megawatt hour, and floating wind should see the LCOE going down to $96 per megawatt hour. What is the situation currently in Norway and Portugal? Some of the things have been already said from Paulo Partidario and before also from the ambassador, but I will try to summarize. So first of all, Norway has currently the largest floating offshore wind farm operating completely since 2023, which is Hywind Tampen. And instead, here in Portugal, we had the first semi-submersible commercial project, which is Windfloat Atlantic, that we know quite well. So that positions us and Norway to be floating wind pioneers. In terms of auctions, Norway is slightly ahead. They had the first auction during 2024. It was for a bottom fixed area of 1.5 gigawatts, so Sørlig Nordsjø, and the winner was Ventyr. Ventyr is a partnership between Park Winds and Inca Investments, and for who doesn't know, Inca Investments is actually the owner of IKEA. The second auction, which is for floating Utsira Nord, was going to happen in 2024, but it was postponed. We are waiting it to happen next year. It should have some qualitative criteria. It will have 3 areas of 500 megawatts, but just one of these areas will have support from the government. I won't mention much about Portuguese first auction because Paulo just touched upon it. We just note that there will be the sequential model, and we hope that the seabed allocation will happen next year. In terms of offshore wind areas, so we are all waiting for the PAER to be approved in Portugal. There were 6 areas under consultation until the end of last year. We know there may be some changes there as the results of the consultation. Instead, in Norway, there are 20 areas being analyzed since 2023. We, as DNV, have been supporting NVE, so the Norwegian Water Resources and Energy Directorate, doing an impact assessment. And the latest results from the impact assessment for 3 of the areas that were actually announced just a few days ago. So Servest F, which is the contiguous area to Sorlik Nordsjö, and Vestervind F, which is the contiguous area to Utsira North, will have new licenses being considered. And the third priority area, which is Vestervind B, will actually wait for the results for the whole strategic impact assessment, which is predicted for the Q2, to understand if it should be or not one of the next sites to be auctioned. Looking at the goals, so Norway has this huge goal of 30 gigawatts to be allocated by 2040 and aims to capture 10% of the international offshore market. Instead, Portugal, we have a smaller goal of 2 gigawatts, but also under a much shorter timeline, 2030. After 2030, our national plan says that additional auctions may be launched up to 10 gigawatts. Just to finalize, what are the drivers for these huge goals in Norway? I think it's worth to say that Norway in this moment has a power deficit, so they need a scalable option to answer to this electricity demand. The electricity demand in Norway, by the way, is expected to double by 2050, and wind is the answer to this because either cannot be expanded in such way. At the same time, we have a very strong maritime and oil and gas business in Norway, and it can be leveraged the expertise, but at the same time, we can use offshore wind to decarbonize those industries. We are already seeing electrification of oil and gas in EV Tampem. There are other projects under development like Goliath Wind, Snøhvit, and Brage. Wind resource is also very favorable in the North Sea. We speak about more than 10 meters per second at 120 meters high, while here in Portugal we have 8-9 meters per second. And differently from Portugal, Norway can export to a number of countries such as Sweden, Denmark, Netherlands, and Finland. We have done an exercise in the DNV to understand if the 30 gigawatts are achievable, and our conclusion is that by 2050, Norway should only achieve 21 gigawatts, which is still a very good goal, by the way. But we expect 9.1 gigawatts to be for bottom fixed and 11.5 gigawatts for floating offshore. And most of the installations to happen between 2032 and 2037. Just to finalize, these conclusions I gave about DNV predictions are all present in the energy transition reports. We have a global report, we have a report for Norway that was launched last week. And today, actually at this moment, we are launching in Madrid a report for Spain. So you can download for free. You can also assess the data behind it. Thank you so much for listening.
Thank you, Daniela. I must say I'm a very lucky man. I have 2 keynote speakers who actually kept to their time. So it's wonderful to manage a panel like this. If I may, Daniela, just to a couple of points for those who know a bit less of this. There are a couple of differences between Norway and Portugal. For example, the high wind Tampen, it's been set up to be injecting on oil and gas facilities, which is quite different from what we have in the Wind Float Atlantic, where the injection is on the grid. That brings a lot of differences. There's no point in discussing that, but it's a big difference. The other aspect that it's perhaps, Daniela touched upon it, the areas are going to change. Apparently, Vienna South is no longer going to be available, but the other 2 areas in the north, the Vienna North and the Leixões, are going to be enlarged in order to meet the goals that are ready. So just these couple of points to enter the discussion. And now with the discussion, I'll introduce our panel. From your left to your right, we have Gunnar Birkeland. He is the CEO of Source Galileo. Well, it suffices to say that they are now involved in the Goliath Wind, which is a test project in Norway. It's been subsidized by the Norwegian government to test the technology and see how it goes. It's one of those projects that everyone is looking at to see how it goes. Gunnar has been involved in all sorts of activities relating to the oceans. So he's a man relating to activities in the ocean, and is one of the highlights I got from his bio Museu is that he operated the world's first floating turbine. So there you have someone who actually puts his hand on the job. Inigo Vianney is the general manager of Care Renewables Iberia. Is establishing the company operation in Spain and Portugal, not just offshore wind, in a number of other areas relating to the energy transition, new energies, let's call them that to encapsulate in one. He has a very big experience in large-scale projects across Europe, Africa, and LATAM. So he's also a man that has dealt with these renewables issues. And certainly, finally, but not the least, Ricardo Rocha is the technical director of offshore wind at Baia. Ricardo is a geologist. He's been involved in 20 years of geology experience across a number of fields. Is looked into, for what it matters here today, to the full life cycle of wind, both onshore and offshore, having deployed about 10 gigawatts, if I'm not mistaken, across a number of jurisdictions around the world. Actually, it's 20 gigawatts in 10 jurisdictions. The numbers were the other way around. I will start exactly by you, Ricardo. You've just heard the GEG speak about what to expect for the coming auction. I recall that Baia in early 2022 made a submission to the Portuguese government. And if I recall, it was a subsidy-free kind of planned project. What did we miss there? Please, let's keep to 2.5 minutes so that we have time for Q&A.
Okay.
So what was missing there for the project to go ahead?
I will try to be short. First of all, thank you very much for the invitation to be here. It's a great pleasure to be with this panel. Yeah, indeed, it was not 2022, it was actually 2021. We proposed the first subsidy-free floating wind project in the world, using the area on the maritime planning that is dedicated to renewable energies. And our proposal was to build a commercial project of 600 megawatts before the end of the decade. We tried to secure the exclusive rights by two means: private initiative allocation plan, and then we tried to apply to the 2PEM. Both of them had been rejected, so we had to cancel that.
Okay.
And meanwhile, we won the first floating wind tender in the world, which, again, with all the learnings from that process.
Just to pick on your brains, but subsidy-free in floating offshore wind, that was possible in your view?
At that time, yes.
At that time?
The world has changed.
The world has
significantly.
changed since. Yes,
And,
that was the point I was trying to get at.
Yes.
In those days, it was possible to think about it,
Indeed.
not anymore, because much changed, notably materials, prices. have gone
Turbines,
up,
particularly.
Turbines, especially. Supply chains are no longer in place. Gunnar, this shows what Ricardo just mentioned, shows the risks over long-term projects, such as the ones we are dealing with. Things change very rapidly. In 6 months, we turn the world upside down when it comes to these matters. How do you see these managing of risk and cost in large scales? You just apply for the Goliath Wind. Can you share with us how you see these management of cost risks in these kind of large-scale, long-term projects?
Yeah, absolutely. Thank you for the question. It's important. First of all, very good to be here. Thank you. I think the cooperation between Norway and Portugal is important for the whole of Europe to succeed in floating wind. Just also want to say that we have a special interest in Portugal with our partner Inca and the local company Portland Hill have applied the letter of interest for the upcoming auction. So we have every reason to support it will be successful. And a success, I would like to start with that. A successful auction is when you have a successful development at the end and you have job creation locally. To start on that journey, you need predictability. You have to look at everything from an investor's point of view. If you want investment in supply chain, if you want job creation, if you want successful auctions, you have to see it from an investor's point of view. You have to de-risk. You have to create an environment with as less risk as possible for the investors. And then there are certain conditions that have to be met, because the risk is cost. So when we're talking about cost in the floating wind, we talk about scale and industrialization and so on, but we have to start with de-risking the first project. It's not a race about opening the first areas between the countries. It's a race about creating the first safe environment for investors to invest in. Then you need predictability. For the supply chain, you need predictability in the pipeline. But for the investor, you need to have de-risking the first project. So back to Goliath. Goliath is a good example of a pre-commercial scale project where you're testing full-scale technology. By that, you will make the big project, the first auction, bankable. And you'll reduce the cost of project finance. It's something we don't talk too much about, but it's the most important thing now is to reduce the cost of project finance, to make everything bankable. So creating this safe environment for investors, that will unlock the further investments in the supply chain and the job creation.
And those pre-commercial projects can actually help you convince DNV to undersign the technology so that insurance can be taken out on the project and make the bankability of projects much more viable.
If I may just reply on that, that's a very important point. You know, in the maritime legacy industry, we used to, DNV started doing the basic design approvals and certification of ships. That's the exact same regime we have to apply for floating wind to make sure it's basic design approval, certified, etc. That helps make everything bankable. So,
wonderful. Inigo, you've heard these two interventions. Along these similar concerns of mitigating risks and challenges, you look at the Portuguese setting, you're interested in investing in Portugal from the perspective of potential promoters, investment, stakeholder engagement, all those things. How do you see those boxes being ticked for an investor like you so that you can be comfortable, as Gunnar said, to make an investment in Portugal?
Good. So let's say I think that the check in the box still in the, let's say, in some desks. Okay, so we're still working for it, and we're still waiting for, let's say, to see how it will happen. The reality, as Gunnar has said, and for sure also our colleague from BayWa will tell us, is that, let's say, moving into offshore floating wind in Portugal will require, let's say, a large investment in industrial means for projects to be built. These are bulky, and this is an enormous opportunity for Portugal. Okay? So I think that real industrialization of the country can happen if all the boxes are checked. This said, let's say, based on our experience, let's say, in onshore, but also in offshore, for example, in the tenders we are participating in France, or the projects we are already developing in Scotland with, let's say, quite similar schemes as what we can see here in Portugal, is that, let's say, we need to have visibility. What means that if, for example, we have a two-phases auction, okay, so we'll have, let's say, a time to analyze the seabed and to see where we'll be, and thereafter we will be participating in an auction to get a tariff and the rights to inject the energy. Let's say this is something that could be done, but for sure, we need to secure the investment we'll do, not only ourselves alone, but also with partners in ports, in metal industry, and so on. So we need to have visibility on this to ensure that the day we will finalize these studies on the sea, the day we will succeed in the auction, God bless us, we'll be there manufacturing and not waiting extra 5 or 7 years for this to happen. Okay, so for us, one of the most important check in the box to move from the PowerPoint to the power plant will be to have visibility and to have volumes there.
Thank you, Inigo. Ricardo, back to you. We've heard Paulo say industrialization, Gunnar say industrialization, Inigo said industrialization. So floating offshore wind supply chains in Portugal, can they happen? How do you see, from Baya's standpoint, how do you see that being materialized in Portugal? What requirements, what expectations would you like to see there for those supply chains and that industrialization to take place?
I think the key word is visibility and certainty. Without these two, I would say, keywords, it's impossible for any player in this industry to make a meaningful investment because, you know, again, 10 gigawatts, 2 gigawatts in the PowerPoint, it doesn't provide you the basis for you to make an investment. Actually, the Greenfield project that we used to call the Vienna project, that was aiming to give that visibility to the supply chain. And in that process, we established several partnerships with many local companies, with local ports, to prepare for the delivery of that 600 megawatt project. Some of these partners, they haven't seen probably the future of offshore wind, and they have given up. But other partners, they stick to the plan. They looked for other possibilities to play in the market. They looked for visibility in other countries, and they achieved it. And you will see today in one of the presentations, one of these examples of a company that we have been collaborating for the last 4 years that decided to make an investment in order to become a player in this industry. With the visibility that exists, unfortunately, in Portugal, there is no visibility.
Okay, that's the one point I want to pick up, and I'm going to ask a question for all three of you to answer to the same question. I've heard visibility, predictability, certainty. That must mean something in very concrete terms. One of the issues that in talking to stakeholders, one of the issues for investors has been how, and looking at the timeline that Paulo showed about the auction, how do we go from investing in surveys, studies of the areas, to the TRC / contract for difference auction, let's put it simply, bidding for a price, a strike price to be working with. My point being, right now we know there's going to be a TUPEM, and then there will later be the auction for the strike price. The issue is, how do we transition from one to the next? And my question to the three of you is, what requirements do you want to see there to ensure predictability, visibility, certainty, so that the investment can happen? Gunnar, we can start with you now.
Okay, thank you. Yeah, I think there is a lot the government can do to make it easier, right? It's about making it easy. And we have, I think, a good experience in Norway with the cooperation between the industry, fisheries, and the developers, for instance. That takes some time and to create this trust and environment to find solutions together. Very important that de-risk, conflicts. Then the preparations to understand, what area you're going into, and as much data as possible available for the investor is a second, of course. But then I think the elephant in the room is the subsidy scheme per se, because we see across Europe, and the wind is changing, the pendulum is going from left to right all the time, and it's going right-bound, and there is an opposition against subsidies for floating wind, because people are unsure, will there be jobs, will it be value for me, will it just increase the power prices? So I think back to the visibility is to make sure there is a public acceptance that they understand there is job creation, and that there is a predictability in a long-lasting subsidy regime. Because I think that's we can't hide that floating offshore wind is expensive. We haven't really started the learning curve. We have to enter this learning curve, and then we can talk about industrialization, scale, etc. But the first project to be out to be able to kickstart the supply chain and job creation is tricky and will cost a lot of money, and we can't hide that.
I will take one point from your answer, which is there has to be public acceptance that something is going to be subsidized, otherwise it will not happen. I think this is critical, and if we do not put this in our heads, floating offshore wind is not going to happen. It is as simple as this, in my humble opinion, but I'm thinking that these gentlemen can even answer better. Gunnar already said. Inigo.
So let's say on our side, and based on the experiences we are having both on onshore and offshore wind in other jurisdictions, fully agree with you, Gunnar. So it's to have the project accepted by the society. If not, it will be very hard for politicians to boost and to move forward. That's one thing. And then we see two very important things, okay? So in a scheme where we'll be having, let's say, a two phases competitive tender, let's say we must ensure that this will happen. What means that learning what has happened in other regions, like, for example, not to mention the US, okay, to have, for example, let's say Rocket Sky bids for a non-exclusive bidding zone. That's something very important for everybody, okay, to avoid anybody, let's say, banning the others to make things or for this to happen, okay? So that's one very, very important thing for all of us. And let's say the second one is also to have, let's say, the certainty that, for example, these studies on the sea will happen. Okay, so will be, I don't know how many developers running their own, let's say, kitchen on the sea, and we need to ensure that all these means will be available for everybody, let's say, minimizing the cost for each of the developers to carry out those studies, okay? So let's say for us is to ensure that this will happen, avoiding having speculation on the seabed list, for example, and second is ensuring that all the studies and all the means on the field will be there, let's say, a reasonable price.
Wonderful. And I'm going to also take one point from you and then make a challenge to Ricardo. And the point I will take from you is you can't have people running around their own shows and collecting data that are subsequently not integrated and not worked jointly so that you can have a level playing field once you reach the bidding for the strike price at the CFD. Ricardo, I'm challenging you to add a third, very important point for this debate, other than those two that we already had.
So I have to say that I don't totally agree with my fellow colleagues.
I expected that. There you go.
But I don't think we should take that maybe to another discussion. I think what is important first is to detach floating offshore wind from the oil and gas business.
Okay.
There's a tendency to mix the two, and I think that's very wrong for many reasons. I think that floating offshore wind is closer to fixed bottom offshore wind, and it's closer to onshore wind than it is to oil and gas. The reason for that is that we are under pressure since the beginning. Money and borrowed money is not something that comes at a low cost to renewables. It comes to oil and gas, but it not comes to renewables. And that's very important when you state that you need subsidies to industrialize. Yes, if you have a certain plan, but if you have another plan, which is to develop a solution that is adapted to the site conditions and to the existing supply chain limitations, then you don't have to invest on that infrastructure with the money of your project. You use the money to build the project and to deliver the project, not to upgrade ports. Why should you upgrade port if you design a solution that can fit on the port you have available for your project? I think that is a key difference for us. I try to do the parallelism with the fixed bottom, which is where we have at least 25, 30 years of experience, close to that. The first turbines have been founded on gravity-based foundation in this industry. And then we picked up an oil and gas solution, the monopile, and we have expanded it to almost 30 times the size of the first ones that have been installed, and it continues to be the solution that represents 92% of all installed capacity in the world. So basically what we need is to find the floating offshore wind monopile. And it's very difficult in this environment that we are working now, where there's more than 134 floating technologies trying to reach the market, but that are, of course, working on the speculative or in the speculation of what that market would be, which is the certainty we need to deliver it. So I tend to do the parallelism. What if someone would have patented the monopile 30 years ago? We would not have a fixed bottom industry. Think about it, and yeah.
Well, you delivered on my challenge that you raised the third point, and it's technology. Which technology to use, and technology maturity, which is going to be an issue, because even between the two moments of the auction, you have the allocation of the 2PAM. 3 years down the line, you have the bidding for the strike price. That's a long lead time for technology development. So there may be surprises, there may not be surprises, but we need to take that into account. Gunnar, you and Inigo have 30 seconds each, because then I want to go to Paulo and Daniela to hear about this and open to Q&A. So 30 seconds for you, 30 seconds for Inigo.
Yeah, thank you. No, I think don't make the mistake believing a floating offshore wind project is the same as bottom fix. It's very different. I agree, we are not doing it as an oil and gas project, but oil and gas in the North Sea and floating wind are built on maritime traditions. It's the maritime competence we're using. And then we are picking the best technology from the oil and gas. But floating wind is completely different than bottom fixed. That's, I think, is very important to understand.
Gentlemen, ladies and gentlemen, they have two different views on whether or not they are similar. Inigo.
In regards with technology, I fully agree with Ricardo. Let's say we have two things, okay, two very big things. One are the wind turbines, the other ones are the foundations. So let's say in regards with the foundation, we have, I don't know, more than 30 different technologies, let's say, and then the decision will be done maybe, let's say, on the site characteristics, but also in what are the facilities that are available in the region.
Okay? So let me pick your brains on that very quickly. You think that the type of site will influence the type of technology that will be adopted?
Yes.
Very good. Thank you. Paulo, we have 4 minutes. I'll give you 2 minutes, 2 minutes to Danielle, and then we open the Q&A.
Okay, thank you. I'm missing this discussion, and I mentioned that I think it's crucial making a parallel with what is happening with hydrogen and derivatives. It is risk analysis. We are not talking about risk analysis, and this is key because, in fact, we don't have just to cover the funding gap of a specific project with the specific technology that is emerging. We have to think about all issues around that in the context, in the macroscopic approach to the investment, to the competitors, because this is all about competition. The one that will achieve that first will get more gains than the others. And I think here we have already experiences, and we have to learn from those experiences also in Europe. And I will not mention names, but if we have cases where the pension funds are being involved in this type of financing the risk, it's because it is possible. Thank you.
Okay, that's a very good point, because I mean, we have heard from Gunnar in the beginning, bankable projects. Bankable projects means convincing these pension funds that they want to invest in this technology. That's what bankability means. It's not just project finance. It's also having these huge funds coming forward and say, no, I'm interested in having this. Daniela, your views on what you've just heard.
I want just to comment on one thing, which is the cost learning effect that I was also mentioning in my presentation. I think it is very important. We arrived at a moment in which we need the technology to mature. So innovation is very good, but we see a number of designs and concepts for floaters. And if we really want floating offshore to become competitive, it will be important to define a restricted number of concepts. So I think this is a message.
That is a critical point, because you can't build supply chains if each company goes its own way and say, I'm going to build this turbine, I'm going to build this structure, because it doesn't work. You have to have 2 or 3 selected technologies where the companies will go, I go this way or that way, or I go in even the two ways at the same time, but you can't kind of go everywhere. Another question I have quickly for you, how big can wind turbines for floating offshore wind get?
That is a very good question. That
Thank
is
you.
also an issue that is happening, what we are seeing with manufacturers, because they are seeing the loss of profit and margins because they keep wanting to grow. And I think we arrived at a moment in the industry that we need to make the technology less expensive. That should be the priority. Yeah. So not so much continue to grow. We are already producing enough, but we need for the technology to be cheap for the developers, or otherwise.
So are we going to stay around the 15 mark, or are we going to go bigger?
That is a very difficult question.
Okay.
I would need to do a study there.
Well, that's what interests people, because the amount of platforms that you put out there depends on the size of each turbine. If the turbine is 15, it's one thing. If the turbine is 20, it's an entirely different ballgame, I would say. So Gunnar says it's not going to stop at 15.
It's not going to stop at 15.
It's okay. One final question. We have 50 seconds. 15 or bigger?
Bigger.
Bigger. Gunnar?
Yeah, definitely. We'll see in these auctions 18, 20, 22 megawatt turbines for sure. Yeah.
Inigo?
Bigger.
Bigger.
It's going to be bigger. I'm not sure if we'll have European
Danielle,
manufacturers.
DNV views to...
It will be bigger, but I hope not much bigger. That's the point.
Okay.
Because otherwise it will come at a cost.
Thank you to you all. Thank you for indulging me in this kind of quick questioning. We have exactly 10 minutes for Q&A. I would like to open the floor to questions from anybody in the audience. I would ask you to please introduce yourselves very briefly, be short and to the point, and if possible, tell which of the panel members you wish to address the question. If not, I will choose.
Hello, everyone. First of all, thank you. It was a very interesting discussion indeed. I have more than one question. I will put it to one. And let's grab on just what we spoke about. I'm always very curious to, well, it's a bit obvious why many times developers want higher rated turbines to be deployed and so on. So you, for the same capacity, you have less turbines, less cables, less structures, less material, basically, less capex. But I would be curious to understand from your side, so maybe for the three of you in the right, if you don't see that as a project risk also nowadays, because we see GE canceling, we see Siemens Gamesa blades that are having a lot of problems, I think, in vineyards. I would like to see your comment, because if we speaking about risk, that looks a little bit like risk to me, I would say. Thank you.
Okay, Gunnar, you want to start and go on to the...
Oh, yeah, but it's not only about bigger turbines for the project and less floaters. It's about what's available. Because, you know, when we started planning floating wind years back, we thought 11, 12 megawatt was the one we are going to design floaters for. And suddenly those will never be available for the floating market. So it's, I think from an investor point of view, is what will be available, what will be certified, what will be, you know, approved for this. Then I think your point on 15 plus is a completely different ballgame than what we have seen. So far we have seen demonstrated 10 megawatt or less. Going beyond 15 is a different planet. And therefore, back to the risk, you have to see pre-commercial projects like Goliath Wind to demonstrate those full-scale technology.
Just to give an idea, the three turbines at the Windfloat Atlantic are 8 megawatts. So that's a half of what we're talking right now. Inigo.
So let's say, I just answered that it will be bigger than 15, but I also agree that, let's say, not much bigger. We see two reasons, okay? One is that at a point in time, the cost rise will be exponential and not linear. And then you will have a trade-off on what is cost. And besides, as Gunnar is saying, let's say you can't rely on only a couple or one supplier, okay? So at a point in time, we will need to have all the people manufacturing products and technology that are available on the market. Shit happens, it will happen, and we need to manage the risk, okay? So that's why, let's say, I think that the trade-off will be in the range of 15 and 20, something like this. Our current wind turbines in France, or the ones we are, let's say, building in Elmed are 10 megawatts, okay? So, and that's quite big also.
Okay. Thank you, Inigo. Ricardo, addressing that question, I have a different challenge for you as a Portuguese. Is there an opportunity for Portugal, starting from scratch in building the supply chain, in looking what is happening and then designing the supply chain for the best option? So if you could address that question and my question at the same time.
And then I'll come back to you. You might have to remind me, Nuno. So definitely yes, it's a big risk. Having been in this industry more than 10 years, I have delivered projects from 3 megawatts to 15 megawatts, fixed bottom, most of them, one of 10 megawatts in Portugal, floating. It's definitely a risk, but so far, it's been the OEMs pushing for that. That was a key for the OEMs to compete between themselves in order to bring prices down by reducing numbers of positions through the increase of the turbine. But unfortunately, that formula seems not to be resulting. And what you've been hearing from almost all, which are 3 actually, OEMs that we have available to offshore wind, actually 2 now, that formula was not the right one. And one of them, the Danish one, decided to step back 1 year ago and to say, we stick to this until wherever we will say it. The problem is that some regulators have embarked on that journey of bigger and better, and the first commercial floating wind auction, AO5, which was adjudicated in May this year, had a requirement to go for unexisting turbines, because it had a minimum capacity and had a maximum number of turbines, which positioned any developer wanting to bid on it, having to bid on paper turbines. So yes, definitely a risk, but if we would not have bidded on paper turbines, we would not have won it. And now we have the challenge to deliver that project because the world has changed. Because during the tender execution, the OEMs were saying bigger is better, and then suddenly they changed their posture. And yeah, we can do floating or offshore wind projects without many things, but we cannot do it without turbines.
Okay.
Coming to your question.
Opportunity in Portugal. Is there an opportunity?
There is an opportunity, but I don't think there's an opportunity to build turbines. Unless,
there you go.
Unless it's a non-established manufacturer coming from a different region than Europe that is established in Europe to produce those facilities. But everything, all the rest can be delivered.
My question has to do with the first onshore wind auction in Portugal in the mid-2000s. People are talking about it, but the opportunities are not exactly the same, and the panorama is not.
And the competition is not the same. No. For onshore, at least we have 7 or 8 meaningful European or Occidental players. In offshore wind, we have always lived with 3, and now we are reduced to 2.
Wonderful. One more question from the audience, please.
Good morning.
Up there seems to be someone in the...
Good morning, Rui Barros from Synergy International. I have 2 questions, if I'm allowed to. One is for Daniela, and is more a friendly request. I would like to know your opinion about standards. Are they enough for today or for the future, or we still lagging behind, and about new structures, seaworthiness, corrosion, and everything else that goes to the sea and safety of seagoers? Do we have standards adequate for that? The second question is for Paulo Partidário. Everybody underlined this is a long-term business. We need to be sure. So I would like to note stability of the legal framework for business. I mean, when we decide for FITs in 2099, or 1999, not 2000, 2002, it was a bold move at those days, and there was plenty of noise. My question is, do you have the legal framework that is adapted for the next 10 years' realities, or do we have the legal framework for today's realities? Thank you.
Thank you. Daniela, 1 minute for you. Paulo, another minute for you.
Now, I think the question on the standards is very good. I mean, it's something that we work quite a lot as DNV. So there are standards in place internationally, let's say. In Portugal, I mean, we still need to understand how things are going to apply. So we need to understand the framework. And what we are doing, especially for floating, there are still some gaps, and we are working together with the industry in joint industry projects to try to take out, to eliminate those gaps. So we are looking, for example, at what exists for oil and gas and other industries and seeing how it can be adapted to oil and gas, to offshore wind.
Thank you, Daniela. Paulo, you want to?
Yeah. Thank you for the question.
Second question.
I would say I would make a parallel here with the challenges we have to build the one-stop shop for permitting. I would say that for value chains and to have this kind of understanding of the whole economical context and the policy framework is inside that same framework. I would say that we need, and I will repeat here what I already told to the Commission when we had these steering group meetings around the set plan and in particular about the implementation of the Net Zero Industry Act. It is very much about how to build or assist the development of the supply chains and the whole value chain as a result. It is not spontaneous, and we learn from the IPCI hydrogen that we need to make the interaction between the players. And that is critical for the companies because they have to know exactly what is in their radar, what should be added to those signals, but also to the game we play in each country in terms of to make the interactions, the necessary interactions, to have everybody on the same page. And I would say that from the policy perspective, I would say that there are missing parts here where we have compartments that still need to learn how to join and to get synergies. Because I can give you a good example. The first call for energia in Portugal was being addressed to ecological technologies. So when someone, as a future promoter, is getting this kind of signal to apply his proposal, is having a mix-up of concepts, of targets. So what we get from those proposals is a mix also of verbalization of words, where they try to adapt part of the call with what is the reality of Tanzania. So all this are challenges, so this is a learning curve. I would say that we have a lot to do with the different policy areas, and yeah. So
thank you, Paulo.
Thank you.
And we've just finished on time. I would like to ask you to please give a big round of applause to our panel members who were fantastic in sharing their views. And thank you very much, ladies, gentlemen, for being here in the panel.
Thank you.
Thank you.
Thank you.
Thank you so much, Nuno, for keeping it in time. Now we are going over to session 2. So building success, value chain developments in offshore wind project for the next hour, and then we are going over to the coffee break. So the moderator will be Arne Vatnooy. He is a communication manager at Norway Offshore Wind, Norwegian Offshore Wind. You can come on stage. And the keynote speaker, Technip Nunvaj, Otchwell Ocean Wind, Kenneth Fossey, please. Martin Melhus from TSGS, Global Maritime, Jose Gomez, and from WavEC, Ines Machado.
Following the structure? Doesn't matter. Nah. Okay. All right. So that means I'm number...
But there's one missing place.
I'm here then.
Por cima?
One missing chair?
That makes sense. Okay. Hello.
Related, I guess?
Yes,
No,
it
no,
sounds
unfortunately.
like the sound is coming and it's coming on the grill. Great. Thank you all. It's great to see you all, I must say. I'm really, to see a room full of people enthusiastic about the offshore wind future is really bringing some optimism. And I think we all need optimism now because there have been several setbacks for industries in both of our countries. We have challenges that we are going to discuss, but I think in this panel with these fantastic experts here, we are going to address some of the keys to success. So I'm really excited to have these fantastic panelists and speakers with me today. It's going to be 3 presentations, and then we're going to have a round table to finish off before our coffee break. So first and foremost, give a big round of applause to these people. I think for our first speaker, I just have to say that I learned something this morning, and a little venture that I would have to say, finding Nuno, because I went up to Nuno Antunes and said, fantastic that you will be in my panel, which he said, no, I will not actually be in your panel. So I learned today that Nuno is a quite common name for men of a certain age here in Portugal. So. So that's a great first cultural experience for me here in Portugal. And Nuno Vaz, I'm really excited to learn more about Technip FMC. We're going to bring our expertise to the table here today, and it's of course important to actually learn from those who have direct project experience. So if you're going to discuss key success factors, I think, Nuno, your perspectives will be most welcome. So please, the stage is yours.
Thank you. Just to continue adding to your note, so when in Kongsberg, among the Portuguese community, we were 5 Nunos. So at a certain point, Norwegians thought that Nuno, everyone in Portugal was called Nuno, because we were 5 over there. So 5 years in engineering studies, over 20 years working on engineering, 12 of which surviving the Norwegian winter. Being a long-term member in terms of the National Society of Chartered Engineers, all of this, and now I'm an architect. So this turned way around for, at least for me, basically. So starting, hello everyone. My name is Nuno Vaz, and I'll be trying to guide you through today in terms of what it means to be engineering architects for floating wind. So as a starting point, what consists the water column? So here we are talking about everything that goes on the vertical column between the surface and the bottom of the sea. And this is where Technip FMC Subsea business unit operates. So Technip FMC, it's a well-known company, EPC, operating on the offshore, so well-known for the integrated and execution of complex projects within the offshore environment under harsh conditions, especially when it comes to the North Sea. And from those harsh conditions and down to ultra-deep water if we focus on the Brazil side of things. In terms of the company itself, so it's been a long journey here. So we have been during almost more than 45 years experience delivering solutions in terms of the cables and umbilicals, manufacturing and installing them. Over 25 years designing cables, also for the offshore environment. And basically, it led to,
Stay. Okay. It led to, at this point, to a proven concept, Technip FMC, and here is where I'll contradict what Ricardo was saying. So coming back from the oil and gas experience now to the energy transition part of it. So a proven concept is Technip FMC's IEPCI. So what IEPCI stands here for? It's Integrated Engineering, Procurement and Construction and Installation. So where we play a key role on integrating all this complex environment of subsystems to install within the oil and gas, and this is what we are trying now to replicate on the offshore wind. One difference here, let me to point out, and coming back to what we were saying in terms of the cost previously. So if you look at what the offshore wind part of it stands, so you have the foundation supply and integration, and you have the turbine supply, which to some extent can be considered a fixed capex across the different projects, because once standardization is in place, not very much will vary. However, the water column IEPCI here is going to increase significantly as we go into deeper water. And here, what does water column IEPCI stand for? So we see it doesn't stay. We see it as a combination of the dynamic inter-array cable, supply, transport and installation, the mooring and anchoring supply, transport and installation, and in some particular cases where we have the right partnerships on board and for specific projects, the export cable supply, transport and installation. As an example, again from the oil and gas that I'll be bringing here, we have successfully executed these projects, and I'll bring this example, the Shell Kaikias project, where through a combination of the Subsea 2.0 and the IEPCI, it led to a schedule compression, a massive schedule compression of 6 months, and a break-even price of $30 per barrel. Again, coming back to what Ricardo was saying, don't use the reference as the profits from the oil and gas into this industry. It's much more tight type of industry. But what I wanted to highlight here is our combination of the IEPCI, as I described, together with the Subsea 2.0, which we have configurable to order type of product solutions to address the specific project requirements and to transfer them to something that could be almost out of the shelf. So pre-engineered, industrialized type of solutions that we have on our portfolio that enables us to save a lot of time and money in order to execute the project. So a combination of these two can bring success into the offshore wind, also as we have been seeing it in the oil and gas. So this combination optimizes the lead time, the execution model, and the predictability and the reliability of the delivery. That, on top of our full vertical integrated product offering, where we do R&D, engineering of the dynamic inter-array cable, we do the manufacturing in our facilities at Newcastle, and the system engineering and the system integration part of it, together with the project management, and in the end, we do the installation with our vessel fleet that we own. By combining the analysis in terms of the cable and mooring, as we do in terms of the system integration approach, on top of all the expertise that we accumulated over these 45 years experience in terms of the oil and gas, then we are able to do a system optimization in terms of lowering the FID risk and also optimizing at a later stage the project execution model. Picking up on this expertise in terms of the developing local supply chains, we have been for many years, both to address the local and the global market, developing local supply chains and engineering hubs, one of which was the Lisbon office back in 2011, when initially created to address and to support operation centers in UK, in Brazil, Norway, France. It started out as a player for the subsea umbilical risers and flow lines. Currently, after 13 years of growth, it continues to support all of these main centers, but on top of that, is also an operating center for Angola and Mozambique projects. In parallel, since some years ago, it started also to have a close cooperation with our Aberdeen and Newcastle teams when it comes to the floating renewables domain and the hydrogen pillar that we have. And for that, we are developing local teams also to support remotely the hub that we have of floating renewable in Aberdeen and Newcastle, but also to address the local content in terms of the supply chain for the future auction and projects in Portugal. So back to the no, it doesn't go. Back to the original question. Why me? Come on. Stay? No. We'll get there. No? So I'll try to summarize. So why engineering architects? Because as global leaders in terms of providing solutions within the energy sector, we continue to look upon the current challenges when it comes to both the conventional side of the business, but also the needs, the future needs in terms of the energy transition and everything that it requires to do the proper moving from the oil and gas business that we have been operating so far, but also the needs that the world is currently in demand right now. Thank you all, and I apologize for the slide.
Thank you. Thank you very much, Nuno. I certainly hope that the technical competence in this room does not reflect what we're going to deliver in the industry. So sorry about the issues with the PowerPoints, but thank you very much for sharing your thoughts. You're going to join us also, Nuno, in the panel conversation after the presentations. Now, speaking of transition from oil and gas, Odfjell is a company heavily rooted in the oil and gas industry. Kenneth, now you've established Odfjell Ocean Wind. We've already learned some of your activities through the Goliath Wind projects, but we are very eager to hear your reflections on how to create success in this industry. And I wish you better luck with your PowerPoints than the previous speaker. So Kenneth, give him a big round of applause.
Thank you very much. I'm excited to see how this works. There it goes. So is it possible to get it back? There we go. Okay. No, so thank you very much for having me, and also WavEC for the kind invitation to speak here. We heard very much good about this event before, so it's very nice to have the chance also to be here and share a bit of our perspectives. My name is Kenneth Fosse. I'm responsible for business development and project development in Odfjell Ocean Wind, and I have approximately 20 years of background from mainly the oil and gas business through working with different energy companies, mostly in Norway. So I'll talk a little bit about making floating wind relevant. We have some interesting experiences. We have tried, we have failed a lot, but we've seen kind of try to always move forward in the things we do. So we come from the maritime heritage. So basically we joined the oil and gas industry when it was basically being established in Norway in the late 60s. And what happened at that time, we are a family company, so we were already established, but a new opportunity arose, the potential to establish supply chain and the potential for Norwegian industry to grow through the new American industry. And actually, the Americans dragged over the drilling rigs that they used in the Gulf of Mexico, they dragged them over to Norway, and the Norwegians scratched their head and, well, this is not going to work here. This is completely different environments than you have in the Gulf of Mexico, but here you needed to take kind of and use the basic you had in Norway, which was to operate in harsh environments. So basically what we are coming from, we have been through the 50 years since the oil and gas inception in Norway, and we worked our ways through designing, developing, building, and operating floating offshore drilling rigs in the Norwegian continental shelf. We worked for companies like Equinor, Total, Shell, and so forth, gaining much experience, to also having these assets, not only build them, but also to operate them for several years. This has learned us something about also the maritime arrangements that have been represented by DNV and so forth, and how to maintain lifetime and integrity of assets over a longer time. We retired recently a drilling rig that we had, a steel semi-submersible, that lived for 37 years before we retired it. And it was not us that retired it, it was actually the market that retired it. So that's something about how we work with things. We are a family-owned company. We are very long-term in everything we do. We construct long-term, we live long-term, and when we engage in the oil and gas industry, we're still there. We've been there for 50 years. Now we ventured recently into the last years into the floating wind. We are there for the long-term game, bringing in everything we have learned from oil and gas. And I think from oil and gas you can learn quite a lot. I'll show on the next slide. I just mentioned the Odfjell group. We are a significant group. So, and now it moved by itself. But anyway, so this is the experiences you can see from what we are taking from oil and gas. And navigating in the floating environment is completely different than bottom fixed. I myself have worked with jackups in Maersk, and I know the difference between bottom fixed and floating. So there's completely different disciplines. And I'll just show this example because this shows what you can bring from the floating industry. What we are doing here, this is basically in South Africa. When Total Energies drill a well in South Africa, they bring a rig from the North Sea down to South Africa to drill the well and then bring it up again. So this is basically having a drilling rig drilling at 2,000 meter water depth, not being moored. It's on dynamic positioning in a river. It's 6 knots of surface currents moving the waters. So that is kind of the environments that we are used to. And then when you're supposed to then design floating units that are supposed to carry 15 megawatt floating turbines on top of them, which are units that have rotor diameters up to 300 meters, you kind of need, what you say, an industrial capacity to do so. So the learnings we take from this is that we bring everything we've learned from the oil and gas. And we have in-house now in the Odfjell Group, we have access to 300 engineers within relevant floating disciplines. Floating is difficult, it's challenging, and we also see it in terms of where we have come now when we look at, for example, design. We've talked about turbines and floaters. There's very many good demonstration projects that have been done, but you haven't yet demonstrated floaters with turbine size beyond 10, 11 megawatt. So there's basically no technology available. When we look at this, we see that once you get to larger turbines, which everyone talks about, you get into more and more challenges. So this is very important to keep in mind, and it's also important to use some of the good things you have from the maritime legacy, for example, DNV certifications and so forth, so that you can bring about what you can say safe and also bankable solutions. So we have basically a company that has evolved a little bit over time. We are a technology company, so we design a floater, but we also leverage our capacity to also do EPCI management and do project execution and develop projects. But we are impatient, and we saw when we started a few years back ago, we were going to be a supplier to the industry and let others build and demonstrate our technology, but the projects never came. So we thought, okay, we need to take an active role. We need to take a hands-on role in order to be able to enable this. And this is also when we teamed up, we have gradually built a company with more and more partners that are part of kind of a club that is wanting to industrialize and develop floating wind. So a few years back ago, we teamed up with Gunnar Birkeland, who you saw on stage now, and Source Galileo to develop floating offshore wind in Norway and take an active position. And we also see, but all the complexity and the dynamics, different turbine sizes. When you go to the supply chain is basically not there. You need to be active, you need to involve the supply chain. There's a lot of interfaces and so forth. To have your hands on the wheel, to be part of having the design, but also work with the supply chain that's going to build and develop that supply design and associated things, but also to be at the boardroom and part of bringing the project forward, having a significant skin in the game is something that we have seen as a success factor. Gradually, we've built our company with more and more, what you can say, a larger and larger club. We brought in, as you may see, several Japanese companies. The Japanese are coming in because they want to learn. They really, really need this because of energy security. They don't have much choice, so they really come into these projects. And what they are looking for, they're not looking for projects that are only in consenting or in grid and so forth, a typical developer. They're looking for substance. They're looking for someone who executes real projects and who are developing the supply chain properly. And we have invested heavily also in that part because we see the importance of building a supply chain. That's what everyone is talking about here, primarily through, or first of all, through demonstration projects. So we have our own floater design. It's a steel semi-submersible. That is what we know. We think it's a good material to build on. We have what we call now a deep sea star. We had to change the design a few years ago because we had a design for 11 megawatt. When the VTG makers changed it up to 15, we saw that the design we didn't scale. And it's really important that when you make a floater design, it has also come up to some extent in the debate today, that you make a floater design that's relevant today, but also in the future. Because you're supposed to build a supply chain that's going to build this, you need to have something that is scalable. So we have thought about this around a product thinking. We have a design now that is relevant for larger turbines. We use this multi-locational approach. So we don't design for a specific project. We design for a larger operating envelope. That's the same thing we've done for the drilling rigs. So we've been operational in west of Shetland, North Sea, Norwegian Sea, Barents Sea. So we design this to last for all these kind of different environments, meaning that when we do our qualification using the maritime part, go to DNV, get the certification, we certify the product for a larger envelope. And then further, it's also key, as we see, to build in for this mass production, to have shallow draft and make it also universal so that it can fit for other places, so that you have a standard product relevant for different countries, but also relevant for increasing turbine sizes. So the way we do it, we have our own floater design and associated philosophies and ways that we are kind of thinking. So that's it, our core. Around that, we are now maturing a supply chain that is able to kind of deliver and build on that kind of design. And then we are also gradually moving towards how integrating this maintenance and operation part of it. So this is, of course, a lot of thoughts and theories, but this is actually what we are doing in practice. So we are now having 2 projects in our portfolio. The first one is the Goliath, which is a 75 megawatt demonstrator in the Barents Sea, north in Norway, where we are going to demonstrate 15-ish VTGs, where we're doing 5 times 15. So this is a small-scale demonstration project, also that something that Gunnar talked a little bit about in the panel debate. One of the projects that is supposed to enable supply chain, be accelerated, and also be a pre-project that can be part of taking down the LCOE for future projects. And then we're also bidding for the Utsira Nord, which is the Norwegian concessions that was also mentioned here by Daniela. And a key part of this is that we are doing this as a pre-project to take down costs on Utsira Nord and de-risk the Utsira Nord, bring down the cost. So what are we doing at Goliath Wind? When we look at projects, there's 5 things that we need to tick in the boxes. First of all, technology. We are demonstrating floating technologies or floaters for relevant VTG sizes, which is approximately 15 megawatt for this project. So we're demonstrating technology, and there's also some other technology qualification that will go on in the project. We are in the tender phase, so I will be cautious about saying too much about that, but you can see some of the illustration here. So we're demonstrating technology. Then we're also demonstrating the supply chain. We need supply chain to deliver on this design, as I mentioned earlier. So we have all the packages out for tender. I'll show that on the next slide. Further, we also on consenting is also a key topic, and I think here we have been fortunate to have a good dialogue with the Norwegian government. So we will be the first project under the Ocean Energy Act. We will get an exemption from competition and an opening of area. So we recently received approval of the EIA program. We have done the impact assessment and will now submit the concession application, where we believe we can have that in hand late next year. And then on the grid side, Norway, because this is a special project because you already have power from shore cable. So this is energy transition in practice. There's already a power from shore cable that the oil and gas installation that you can see the FPSO on the side there is already utilizing to bring power from shore. That's an AC cable. So the infrastructure is already placed, the grid is already placed, so we can use that to send power to shore. So this will also, and there's a lot of these cables in Norway with a significant potential to build wind farms. So this will also demonstrate that part of the interface towards an existing platform, and also the commercial arrangement around this. And then we also brought in, we got Enova support of 175 million euro, a grant in competition with 7 other projects. And with this project, the basis this project got it from was that the project was the most mature, because Enova is looking for the most mature project. So we are now looking at a COD target for this project in 2028. And we will also, as part of this, but I won't go too much into it, there's also a project financing part of it. So here you can see all the packages that we are doing, again, enabling the supply chain. All of this is on tender. So we are, so all of this is on tender. So we are enabling that. Then, just quickly, I'll just do that as a segue into the debate. We have a product. If things will converge towards semi-submersible and you get some designs that are relevant now and in the future, there's also a possibility to do industrialization. We have looked at automated production. We see that there is a potential to do these kind of things, but you need projects. That's the key. You cannot do this without projects, but there's significant inherent potential within floating wind to do industrialized production, look at production lines, find inspiration from, for example, Airbus that produces 600 of the 320 series a year. So you need to look at other industries than oil and gas for this part of it, bring the best you can from oil and gas, and then look at industrialization from other industry and do this kind of automated production, enable local production. 1 minute. So making offshore wind relevant, bottom fixed has done it before. And the thing is that bottom fixed was also expensive. When you had done approximately 10 gigawatt of bottom fixed, you started to see that the costs started to decrease, and that's 10 gigawatt. In floating wind, we've done approximately 200 megawatt. So we got a lot more training to do before we get there. So I think we need more projects, probably larger turbines to get the scale. We need industrialization, standardization, and those things can first be enabled by doing projects, pre-commercial projects, to get things started. Thank you.
Thank you, Kenneth. now to create successful value creation in offshore wind, we of course need insights and data, and TGS, a large provider of a lot of things, but among that. So please, Martin, the stage is yours. Give him a big round of applause.
Thank you for the introduction. And thank you for the organizers for inviting us here to basically be able to present our value propositions to offshore wind. So, as mentioned initially, TGS is a major energy data company. As other companies here, we have decades of experience from oil and gas, delivering the full seismic value chain. But we use this expertise and experience to derive bespoke solutions for the new energy sector, focusing them primarily on carbon storage and offshore wind. And it's really the value proposition for offshore wind that I will touch upon here today. So we offer everything from, let's say, the intelligence from our 4C platform, where you get a lot of insight to the industry as a whole. We also have a massive multi-client data library, originally acquired for oil and gas, but it covers major or most major basins in the world. This data can be repurposed for site characterization and offshore wind. We also have a wind data library through multi-client LiDAR campaigns that we keep developing and are looking to expand. We currently have 8 seismic vessels in operation globally, where 1 vessel is dedicated to offshore wind. That also includes the other geophysical measurements in operations. We have ocean bottom nodes, which is mostly relevant for shallow water areas, but can also help resolve complexities in the subsurface. TGS has a strategic ambition of delivering knowledge. So we have put a lot of effort into developing bespoke solution to bring out the full potential of the ultra-high resolution data that we acquire. And we also have various digital platforms to extract value from both assets and to optimize production. Speaking of our integrating offering for offshore wind, so we have successfully entered the offshore wind market. We've acquired 7 multi-client LiDAR campaigns, gathering wind data, both in Germany, outside Utsira, offshore Norway, and 4 campaigns, East Coast US. On the site characterization side of things, we have now completed 4 large-scale, ultra-high resolution 3D surveys. The largest is more than 600 square kilometers. And in the last one, we have incorporated all the other auxiliary measurements, so basically providing full coverage of ultra-high resolution seismic, multi-beam, side-scan sonar, and 2D profiles of sub-bottom profiler and MAG in one operation. We are still fully integrated, so we also deliver the final image products and also have a G&G team that can support and basically provide the subsurface insights. Oh. Let's see if it stays. All right. Going on to our multi-client LiDAR campaign. So the multi-client is a commercial concept that is quite common in oil and gas. And I like to look at it as a kind of a win-win concept, where everyone shares the benefits of the synergies. So for the multi-client LiDAR campaigns, basically TGS has identified the sites and done all the logistical preparations through the permits, the regulatory requirements, and then also working with the industry stakeholders in engaging and also planning and executing these campaigns. So basically the end product here is, of course, the wind resource data, which provides valuable insight to the respective sites that the interested developers can use in their assessments, reviewing the potential of these areas. For the site characterization, we currently have 3 ultra-high resolution 3D systems in-house, which provide full flexibility in the acquisition. On the sketch to the pointer doesn't work, well, the sketch to the left is basically an acquisition setup of 16 streamers with 12.5 meter streamer separation. That gives a saline separation of 100 meters. And that is basically, for illustration, the width of your brush when you paint the site. So basically, the vessel needs to sail every 100 meters to provide full coverage. This is quite equivalent to conventional 2D grids with 100-meter separation. But they will then only give a 2D section each 100 meters. While with these setups, we can provide full coverage and full insight in the site as a whole. All our vessels also have satellite systems and Starlink systems that provides transfer of data live to our cloud-based imaging platforms. Here again, we've used a lot of learnings from oil and gas to deliver bespoke solutions to bring out the full potential of the ultra-high resolution data. I think we bring a step change to signal processing, but some other tools that are worth noting is diffraction imaging for boulder detection, and also quantitative interpretation and data approaches to basically derive soil properties and actually understand the subsurface. So now I'll take you through some data examples just to showcase some of the value of the 3D data. This is a conventional 2D line provided by a developer through the site. And here is a 3D image over the same section. See if I can flip a bit back and forth. That was dangerous. What is clear to see is that the resolution is far improved. The sharpness of the reflectors are better. There's better continuity. The signal to noise is superior. And sort of all the out-of-plane effects you get from 2D are not relevant for 3D. But I guess one of the key or the main important things is really when you do 3D imaging, you ensure that the events are imaged in the correct place, basically providing confidence to the interpretation. Another item worth to note is some of the irregularities seen on one of the top horizons there. In 2D, it's very difficult to assess what is the nature of this, or where does these come from. In 3D, they can actually be tied to scour marks, where you can basically learn a lot about the glacial evolution of that site. And of course, in 3D, you will have that level of detail across the site as a whole, increasing the understanding and enabling informed decisions for your foundation designs and development of this site. One of the really untapped potentials also is data-driven approaches and quantitative interpretation, basically using the data to derive soil properties. Here we're looking at cone resistance over a 3D volume, but of course there's several options here in values that can be extracted. This can help optimize the geotechnical campaign. It will increase the understanding of the site as a whole and not single points that has been extracted, which of course provides full flexibility when assessing and basically planning the development. So with that, I'd just like to highlight that we believe that there is significant potential to accelerate the site characterization process. Having the right data early in the project life cycle means that you can plan, prepare, and basically position yourself for both the challenging procurement processes with the supply chain issues that has been raised today, but also make informed decisions early to basically ensure a timely delivery of the development. So with that, it's what I had today. Happy to take questions later.
Thank you very much, Martin. You are, of course, welcome to stay and listen in on the panel conversation, and we might have some questions from the audience for you, three presenters later. So thank you very much. Now, we're going to delve a little bit more into the topic of success factors to really get offshore wind development going in both of these markets. And I have three fantastic panelists with me: Nuno Vaz, who you have already met, José Gomez, and Ines Machado. And I think, José, I'll start with you, since we haven't really heard about global maritime earlier today, but you do have a lot of project experience also. Mm-hmm. Now in floating offshore wind. I can mention the maintenance for Hywind Scotland, the turbines for that. Can you take us through what's your experience with how we can bring down costs in operation and maintenance in that, from that specific projects and others that you have been involved with.
Yeah, thank you, Arne. So first of all, thank you very much to the WavEC crew for having me here and for this opportunity. As you said, Global Maritime have participated in a large number of projects in floating wind. We come from a long tradition in the offshore industry, longer than 45 years. So what we've done is we've benefited of this knowledge we acquired in the energy sector, and we managed to work on a lot of floating wind, offshore floating wind projects as marine wind surveyors, marine advisors. We also do marine operations like in high wind. And with all this knowledge that we have acquired and we have developed, what we're doing is we are helping projects in DevEx, CapEx, and OpEx stages. So essentially everything now, and this was a common discussion in the previous panel, everything is about de-risking now, so we are taking advantage of all these lessons learned to put them into projects. So when we do this work, this risk reduction, essentially it's about creating credible cases for our clients, developers, technology suppliers, etc. So we do a number of, we work in a number of areas like marine optimization, shared anchors, dynamic cables, etc., and obviously maintenance. Maintenance now is becoming, it's getting more into the focus. I think it was outside the picture some time ago. I don't know if it was High Wind Scotland that triggered this, but my feeling is that it was not very much considered previously, and now it's very much on the scene. So the experience that I have there, it also comes from the bottom fixed industry. Obviously, we have on the preventive maintenance, we need to make sure we understand material selection, the frequency of maintenance of equipment, and the scope of this equipment. This is yet to be developed for floating wind because obviously all these big moving parts won't behave exactly when they're floating than when they are fixed. That's one example. We can take a lot of knowledge from the shipbuilding industry. There's also modern technologies like drones that will allow us to do this kind of surveys without a lot of risk and facilitating operations. Then moving on to predictive maintenance, we can also pick up examples from the bottom fixed industry and use strain gauges, sensors, inclinometers, accelerometers, etc. And then for the floating wind, obviously we have to take care of mooring lines and dynamic cables. So we need systems for the monitoring of the conditions of the mooring lines, for instance. And then going to corrective maintenance, which is basically what happened in High Wind Scotland and also in Kincardine. There's some key points that need to be considered. For instance, is your turbine prepared to be serviced without the use of heavy lift equipment? That's a key question. You need to actually take it off-site, to do that. Do you have access and room in your floater for your team to operate? Maybe you need to bring on extra equipment such as a generator, power unit. If you need to redo cable pulling operations, what is your equipment like to do that? You need to maybe come up with crazy ideas and use additional material because what is existing there doesn't allow you to do it efficiently. What about risk hazards? If you have very small platforms, you're pulling cable, basically you're in a snapback zone all the time. The line of fire is everywhere, so this is a concern. Then moving on to other aspects, do you want to tow your floater to port? Is this port, first of all, closed? Is it available? What about the water depth, the infrastructures? Do you have enough capacity at the quay for big cranes? You need to remove or to disconnect mooring lines, subsea cables. So the sequence that you use to lay cables and moorings, does it allow you to reverse the operation safely and easily, with considering obviously weather downtime and all that? So there's a number of factors that are key.
But for those who don't know this, I mean, the turbines for High Wind Scotland were actually towed into shore, and maintenance was made, and then they were towed back out to the site again.
Yes,
I mean,
exactly.
Do you imagine, with the experience that you have now, that that's how we're going to do it in the future, or do we have to come up with totally different solutions?
Obviously, it's not the ideal situation because it becomes a T&I project itself, as if it was to start from the scratch. It's not ideal. It's very costly. I think it's bound to happen again because realistically, the floating offshore wind industry is quite young yet, so we need to learn, and it's going to happen. And we need to I think we need to start thinking, or rather wishful thinking, that this is not going to happen and prevent when it happens. So all these factors that I mentioned before are important. Then there's unforeseen tasks that come up when you're working on site. So you need to do a thorough survey to see if there's going to be any works that need to be taken care of. There's additional fatigue due to transfer from site to the work site and back. And this has not been contemplated probably in the design life of assets.
Yeah, and speaking of de-risking, Ines, we're focusing on testing demonstration projects. We've heard a couple of those being presented also. But how important is testing at the stage that we're at now for floating offshore wind to get the experience that Jose also is talking about, to de-risk projects, to bring costs down? What's your take on that from WavEC's perspective?
Well, from our perspective, testing is the first stage that supports all the following steps. So WavEC has been having a long history about promoting pilot projects and pre-commercial projects, supporting these developers and project promoters to bring their first trials in the sea. And it's, in fact, where all the technology becomes more realistic and all the uncertainties and important problems arise that need to be solved in a posterior stage. So without testing or test sites that enable project developers to move to these sites with less hurdles and less difficulties, because also all the associated problems of licensing a prototype and testing a prototype. So test sites are the supporting platforms where all of these actions can occur and, de-risk can be brought to life.
But what's the most important aspect, or to put it this way, what's the most important step in the value chain to get tested? Right now, when we have operation and maintenance here, huge costs with the operations that they have done on the Hive in Scotland and Kincardine, for instance. What's your take on that?
I think that it's important at all project levels, for all the life cycles of future projects. You can test everything from the simple material or simple components until all the O&M strategies can be tested, optimized, scaled, and tested in all its dimensions. And also decommissioning, also an important stage not yet thought of during this period that we're going through. Decommissioning strategies. So all of these, let's say, all phases of the project can be enhanced during the pilot phase that can be tested in these areas. So it's really a rather crucial moment for technology development and to achieve technology maturity the so long.
And I guess technology is one thing, but also biodiversity, all of these aspects around that. What's your take on cohabitation, coexistence? How are we moving forward with that in floating offshore wind specifically?
I think it's there are high risks that are still being tackled and were mentioned here regarding technology maturity and scaling up of the technology, which is still yet to be achieved, but it's also a very important opportunity as we are trying to achieve technology maturity, also to incorporate biodiversity or co-location strategies. In one hand, we are designing a new industry, the floating industry. And on the other hand, we have here the opportunity to design it with proper considerations. Nowadays, member states are also, they are very challenged to bring this technology or these projects to to a successful installation. And there are a lot of challenges throughout the promotion of these projects. But on the other hand, member states are also challenged by EU directives that oblige the member states to accomplish with marine strategies, framework directives, marine restoration, nature restoration laws, habitats directive. So in one hand, I think the industry can also support member states to bring these targets to a successful level. And here, by doing a technology development that already incorporates strategies to achieve environmentally responsible targets, I think these are a path that could be done like parallelly. Although I understand that commercially and lowering costs is a priority now to ensure this is a viable industry, I think the industry should go hand in hand with the targets for environmental sustainability.
Nuno, I want to ask you, I mean, what your experience with cables, we're talking about scalability here. Industrialization was also a very big part of the panel. We see some examples on how you can industrialize. Are we missing out on the structures around, such as cables, when it comes to scalability? What's your take on that?
Basically, it's the same as the rest of the supply chain, in my view. So as we are moving towards bigger and bigger projects, so we are starting out 25, going 100 or 50, then 500. So as we are testing the solutions in terms of each of the subsystems, and in this case on the cables, then we would be in a position that we could industrialize, standardize and industrialize more. Because the same thing that happened with the turbines keeps on, the question keeps on coming back. So we went from 33 to 66 kV. When we reached 66, customers start to ask, okay, how about 132? And then 132, why not 220? And then we can miss entirely the substation. Right. So either we have a stable plateau that first we industrialize, standardize, and build up an industry around it. Otherwise, we are always chasing. We are not. No one gets any profit out of it. It's all loss, and the industry itself, it's not built first, and after we may compete. So first we need to build an industry, and then when we are in a position that it becomes a scalable solution across multiple projects, then we are able to compete among this industry.
And what about then the challenges for operation and maintenance when it comes to cables? You have the experience that Jose is talking about here. What are the biggest challenges in your views when it comes to cables infrastructure in that operational phase, maintenance especially?
It's a completely different industry from the bottom fix. So the floating, and that's why we have to bring a lot of the expertise from the oil and gas part of it, because we are operating in very harsh conditions. It's a very dynamic type of situation, a lot of motion, a lot of fatigue. So both the installation process and the maintenance have to be redesigned, have to be very optimized in order to make, again, a valid industry, because so far we don't have yet a floating wind type of industry.
And we're here in Portugal. We've gathered Norwegian expertise here, and Portuguese expertise on floating. But Jose, can I ask you, you're country manager for Spain. How do you view the Portuguese market right now? What's the ability to make business in Portugal if you're in floating offshore wind in 2020?
Well, I think the potential is obviously huge, and that's actually one of the drivers where we now have Global Maritime Spain, because Portugal is one of the countries of interest for us. We see a lot of business going on and will happen in the future. It's true that there's still, obviously, the regulatory framework is still missing. Every time I go to an event, it's something that is going to happen in the near future, but it never ends happening. I think Portugal, when it comes to floating offshore wind, obviously, which is what's going to happen here, is better placed than other countries in the Mediterranean Sea, basically because it's in the route of a lot of offshore vessels. All the operations that happen in West Africa are taken care of mostly by the vessels going to or coming from Norway, the Netherlands, and these northern countries. And the installation of these units is going to demand a lot of these vessels to prelay and install the mooring lines and the cables. And you're going to have operations that last a few days, and to mobilize and demobilize a vessel just for your operation is going to be quite costly, I say. So this is probably going to offset other projects in the Mediterranean Sea, for example, where you don't have such a big fleet of these kind of vessels. But in Portugal, you do have this traffic coming by. So I see opportunities in taking advantage of maybe spot rates rather than to mobilize your vessel for your own operations. It depends obviously on how many operations you're going to have and if you could use economy of scale or not, and then to be a bit creative when it comes to what types of vessels I could use for the installation of my floaters. So I'm very focused on the installation side because obviously this is a specific or special, I think, in Portugal, and also different to Southern Europe. I guess the wind resource is different to the Mediterranean. There's less wind in the Mediterranean Sea. So there was this discussion before about the size of the wind turbines, and I think the conclusion was that they're going to be greater than 20 megawatts. I think that's for sure in the Mediterranean Sea. In countries like in Portugal and in North Europe, you don't really need probably this big, or at least I don't think it's going to be something determinant.
And then as the last question to you, Dan, when we talk about turbine sizes, we talk about allocation processes also, but coexistence is sort of like a thing that goes in all of these things. What can we learn from the Portuguese strategy on bringing coexistence into these processes that we are facing?
I think the Portuguese maritime spatial planning had by design the idea of promoting multi-uses. Since its beginning or its inception, it created areas specifically for multi-use projects. However, at this stage for the planning regarding the offshore wind, that is not yet set in. So I think we're still in the early stage of the planning. I think the planning was very successful in involving all the different parts of the social stakeholders in Portugal. So everyone is heard, and inclusively the areas that are now being implemented have been redrawn based on contributions for the different by the different sectors of the Portuguese maritime industry, especially fisheries. So I guess it was a good job. The main takeaway here is that the areas are a result of a negotiation, a long period of negotiation. So they are quite de-risked at this time, and they will be successfully implemented in our opinion. So this is a good takeaway that we can take from our co-location suggestions for the future. But I do think that there are more opportunities to, now that the areas are defined, that these areas are areas that can promote co-uses. And here also, and I take also this opportunity to challenge the industry to bring this, these co-locations and collaborations together and to engage the local and regional supply chain of Portugal.
That's a challenge for everyone in this room. Thank you so much for being here today, sharing your expertise. I urge everyone to grab a hold of these fine experts in the break, ask them some questions then, because we are unfortunately out of time. But enjoy the coffee and the networking, and give our panelists a big round of applause. Thank you.
Thank you very much, Arne. We are coming back at 12 o'clock, and I'm going to ask the speakers of the next session to come a little bit earlier, okay, to put the microphone. Thank you.
AquaWind is a collaborative project co-funded by the European Maritime, Fisheries and Aquaculture Fund. The objective is to combine offshore renewable energy production and fish farming as a first and unique trial on the coast of Gran Canaria in the Canary Islands, Spain. AquaWind relies on an existing floating wind platform named Wind2Power. It will be integrated with customised aquacultural cage and remote feeding and monitoring systems to track fish health and welfare and prototype structural behaviour. Pilot tests will be carried out to validate the Wind2Power performance in combination with the aquaculture operations, also ensuring close environmental and biodiversity monitoring. AquaWind research activities will be crucial to establish a novel route map for regulatory and legal issues for real implementation of multi-use marine projects. Recommendations for policy makers will also be released to support the commercialisation of hybrid wind and aquacultural technologies. The AquaWind solution will be designed and tested following a multi-stakeholder and circular approach to ensure social acceptance and the lowest environmental impact. This inclusive process will engage at regional, national and European levels, research and innovation stakeholders, policymakers, fishery communities and citizens. With 9 partners from Spain, France and Portugal, the AquaWind Consortium brings benefits from its expertise in the sector of marine and aquacultural research, energy systems, environmental impact assessment, project management and communication. The project is a unique, innovative action to support the development and uptake of combined marine activities and contributes to the Atlantic Maritime Strategy and the European Green Deal for the sustainable expansion of the blue economy. Ultimately, AquaWind will empower business and research in the Atlantic area by laying the foundation for future multi-use projects in the same area and beyond.
The future is green. Or is it blue? The true promise for sustainable energy production lies in the ocean, with floating offshore wind technologies. But alongside the promises, this technology comes with many questions. Will these innovations disrupt marine ecosystems? Could they interfere with fishing and transportation routes? Are these technologies considered within marine spatial planning? Are they sustainable in the long run? A lack of information and misconceptions can hinder progress. To move forward, we need to work towards finding answers. Co-funded by the EU, Marine Wind Project will raise awareness of the potential of floating